Thank you so much. Today I'll be talking a little bit about Blazor WebAssembly, which is a framework designed by Microsoft. And when I was preparing some slides yesterday, I asked one of the LLMs to verify what I did. So he politely suggested that maybe I should remove some slides, so it will be not as big as I planned, because I don't want to be that presentation a tutorial, and I want to shift my focus to architecture. Really, I want to discuss how this approach is different from what we know on our daily basis. Nobody is running, so good sign. A little bit about me. My name is Jakub Grzywaczewski, and by day I am a full stack developer. By night I am WebAssembly, Netflix consumer, and also I really like reading and. Okay, cool. Yeah, I invite you to go to my blog, Memory of Light. I really like prose of Robert Jordan, Wheel of Time. And if you want to connect with me, this is my LinkedIn. So, yeah. Okay, new kids on the block. And some time ago, when I was working in one of the fintech corporations, I was meant to work with a framework I didn't really like. And this framework was called Vaadin. And it was really different from what I knew at the time. This framework doesn't use much JS, really. You have to write your all code in Java, and it brings a lot of, let's say, problems when it comes to debugging, especially when you need to check why some listeners are not removed, and you need to still connect your business logic which is located on server with the browser. And it's hard to believe. Initial release was in 2009, so many years ago. I haven't even started my career at the time. And except the Vaadin, there are a little bit more frameworks which arrived after 2017, I think. Do you know what happened in 2017? WebAssembly. Precisely. And what happened then, the people who like really the languages they work with, like C#, I mean, it was Microsoft, but people who are created U, which is basically using Rust, they figure out that maybe we can actually create some framework which will be working on the browser, but still you can write your business logic, your all code base in your favorite language. So why not? And how it works. Vaadin is a little bit different story because it happened before WebAssembly. And Java developers really like working with servers, so people from Scandinavia, I believe, created that framework, which was just using basic HTML, some JS runtime, really tiny one, and web components. They provided even the whole repository of web components you can use basically in your application, and yeah. You can easily create some back-office apps very fast. But with you and Blazor, I was working with both of them. There is this small difference, WASM. And for Blazor, we'll be talking a little bit more later about it, but you just need to remember that it's HTML, it's the runtime wrapped inside the WebAssembly, DLLs, and JS bridge called JS interop. Similarly, it works with you when you have your build of your app inside WASM container, and also very minimal JS Bootstrap. Have any of you was working with those frameworks? I'm just curious. No. Okay, cool. Even better. Let's move back a little bit. How this normal flow of getting and unwrapping the JS codes you send to the client works. So this is the classic JS flow. It's simplification, but it works more or less the same as you can see here. So first of all, you're getting a JS file, plain JS bundle. And what is happening then? The browser needs to parse that file. Usually, in simple applications, it's not a big problem, but sometimes these bundles can be really heavy. And the process of reading that file, basic checking, it's called parsing. After parsing is done, you are going to the step number 2. You need to build abstract syntax trees. So basically, the structure which will be used by compiler or can be used by linters is very useful after all. So once you have that, you can compile that what you unwrapped from that bundle and compile to bytecode. And there is here it comes GIT optimization, and this is when things are actually interesting. GIT means just-in-time compilation, and just as a reminder, how it works. It's like you are getting your code, and the compiler is reading that and trying to interpret and execute at the same time. So it can easily read which parts of your code are actually executed more than once. And based on that knowledge, it is quite easy to decide. Should I spend a little bit more CPU cycles on compiling that code, and maybe it will bring some speed up when it comes to execution, or just leave it as it is? And when answer is yes, the compiler will compile that code you get from JS, and it will compile it to machine code, and it can really speed up because it will be directly executed by CPU. And then there is a last step, which is just execution. Okay, so what's the difference between what I just described and things when you're using WebAssembly? So WebAssembly flow is a little bit different, and we have that concept of streaming compilation, and this is actually not the same like GIT, because you are not getting a JS bundle, you are getting binary wrapper, which is called WASM. And what benefits it brings is basically you don't need to parse it. Parse it can be expensive. Parsing can be expensive, and the streaming compilation can do actually, for me, magic things. So once you have this file coming to your browser, the compilers can start decoding and validating at the same time when it's still in the process of downloading. So when the head comes to the browser, compiler starting the coding, some short validation, and when the headers and imports are in the browser, it just initializes the module, the whole module, and yeah, after that, it will just execute that code. It's possible that it's the first, chunks of your code will be executed before even the whole thing will be downloaded. So what's so special about WASM? And here's a definition. It's a binary format that's compiled ahead of time. So before you will use your code, you need to compile it. So it's quite beneficial when you want to put some heavy operations in some, language that it's more performant than JavaScript, and in the format which is more performant than your browser used to. So it's actually interesting about WASM, that it brings near native performance. So for me, when I read that about 2018-17, I was really surprised. And actually, one of these creators of that WebAssembly project said if it would happen before, let's say, 2010, possibly Docker would be so big thing after all. So yeah, and what another great thing about WASM is that it's language agnostic. You can write your code in Rust, in C#, in JavaScript if you want it, Dart, Go, name it, and it will be just as good as it should be. Also, because it's language agnostic, it can be also portable and compatible with a lot of architectures. And last but not least, it should be as secure as JavaScript is. So we are basically using the same content security policy and also the same sandbox we are using for JavaScript. And here you have some comparison between JavaScript and WebAssembly. I found that a great tool for making benchmarks, and here you have a link to repository, but you can see that for more complex tasks like some matrix multiplication, calculating primes, WebAssembly would be just better solution. So there are any drawbacks in that perfect world? They are. And first of all, when it comes to build web applications with WebAssembly, you cannot do much really. You have your business logic, it can be executed, but how you will deal with DOM updates, how you will deal with BOM, you still need some middleware here. So all of that frameworks, as you maybe remember from previous slide, requires some JS interop. Because it requires JS interop, complexity actually is involved here. Initial payload, it can be really painful because it will be really heavy, and 1 to 3 megabytes, it's not the worst I've seen. So you usually have to enable some performant compilation. I will show you what the difference is in some live demo. And possibly you need to consider using lazy loading and compressions. Of course, there is not the most painful, but there is still here garbage collector is still limited a little bit. Debugging is much harder than in just JS because you don't have JS. you have your own code you wrote in maybe in Rust, and you have this middleware which is called JS Interop, and you have your WASM in your browser. So good luck with that. And when it comes to Blazor WebAssembly, you may ask yourself, why Microsoft chose WebAssembly really? And this is actually strategy I really like, because it brings progressive enhancements, no plugins required for building those apps, the same security model, and most of all, one stack story. And they want to have C# everywhere. So why not in web? And of course, one of the greatest benefits when it comes to building Blazor applications is that you have a very robust ecosystem. You can use Visual Studio, which is very heavy IDE you can use for building desktop apps, for building servers, and now Blazor brings that to web. Okay, I said that Microsoft invested a lot of time to building that ecosystem, and as you can see here, WebAssembly it's just one of the Blazor parts. So Blazor is the whole ecosystem. They have Blazor server, which was, I believe, the initial release was when they created actually Blazor server in 2018. And it means you have a thin client and you do a lot of stuff on your server. It's quite fast. But when it comes to building single page application, it's really not something you want to choose. So they came up with idea of building WebAssembly, Blazor WebAssembly, and it was released in very early 2020, I think. And it's just the framework you want to use when it comes to building fat clients, a lot of interactivity and things you want to have just in your browser. They also created Blazor Hybrid, which is just for building desktop apps or mobiles, and something called Web App. And I think it will be renamed or replaced, I don't know, by Blazor United. So you have a mix of Blazor server and Blazor WebAssembly. How it works, initial load, it came from server, because when it comes to WebAssembly, you have to download it. It takes time. So you will get pre-rendered website from server, and in the background the WebAssembly will be downloaded to your browser, and you can enable interactivity. So what is Blazor WebAssembly in one sentence? And this is a quote from Microsoft Learn. Blazor WebAssembly is a single-page app framework for building interactive client-side web apps with .NET. So yeah, pretty dense, and I really like that they created that framework, because it just I think a really nice idea to bring WebAssembly to the browser. And yeah, so I wasn't sure if I can show you today anything on my laptop, so I prepared some slides with some explanation how this project is structured. And so I will switch to the my editor. Yep, this is what I wanted to show you. Yeah, let's take a look at the beginning on the project structure. I will increase maybe some font. So as you can see, there is a project called demo. You have a lot of files with an extension called Razor. And Razor is just like JSX in React world. So if you want to build a component or page, you want to use Razor extensions, except that you can see this is basically created from scratch from the tool they provide. It's really easy to create these applications, I mean hello worlds. You will see that when I will launch it, except that we have some configuration files like SLN, CS project, or it should be something like upsetting somewhere. And yeah, this is basically what we have also in JS world. So package JSON, bundler configuration, Webpack, and so on and so forth. And they provide also the structure, which actually solves a lot of problems when it comes to designing the structure, when you want to put your pages, how the routing should working in your application. So they provided folders, layout, and yeah, the most important part here, I mean component here is appraiser. It's just index HTML, index.js, so the root component when you will put some authorization and so on. You have also imports Razor and some components like here. Now I have to. I just want to show you how this component looks like. And this is really simple counter component. On the top there is a directive page, so this just says that it should be found under that URL. You have page title, which will be displayed in the browser, in the tab, and then you have just normal HTML code. It's not JSX, it's just HTML code with some additional directives. And below you can see normal, simple C# code. And I'm going to start it. Okay, hello world. It's just hello world app they provide with that the .NET tools you can use to create a project from scratch. And yeah, you can see that we have that counter. You can click me, it's just working as it's supposed to be. I have some typos here. Yeah, and this is basically how this whole thing works. It's not a devil. But nothing interesting so far. So going back to the presentation. Okay, I will speed up. Okay, so we have additional folders, object and bin are additional places where if you are interested really in the whole architecture and where the WASM exists, when you have some cache and your interop, you just want to go and dive to these folders. Yeah, I said at the beginning that the Blazor requires some additional helpers, and I said it uses JS interop, but how does it really works? How the code is executed. The mono is a runtime designed a lot of years ago just to enable .NET to run on Linux and on macOS, and it's just used here. It's just wrapped inside WASM, and mono runtime is compiled into WASM, and it's enabling C# to be natively run in the browser without any plugins. Okay, so I showed you that page before. You can go to this demo code on my GitHub page. Yeah, and the interesting part here, you have C#, you have JS interop, and how this really working. You have that middleware in between, right? The runtime, but can you actually invoke code from JS code from Blazor? Yes, you can. You can invoke C# code from JavaScript. Yeah, it seems you can. And in this demo, you can see if you go here that we can easily execute it. So we have calls from C#. It will be executed, and at the same time you have here a console log, and you can execute C# from JavaScript. I will speed up, so I won't be diving into this this code right now, but I can, if you are interested, you can go here to interop component, and you will see how all these things works. It just contains some asynchronous methods which can be invoked in both directions. And as well, you have www.root when you keeps your JS interop. And yes, you have JavaScript with Blazor. So when it comes to Blazor, you don't have just C#. You have your WebAssembly runtime and also JS middleware called JS interop, but also you have to provide sometimes a lot of JS. And it's quite normal if you have, package.json here with the whole setup and npm packages. Going back to the slideshow. Yeah, we have also component cycle. And as you can see, you have a lot of methods here. Basically, we have three phases: initial, update, and dispose. And sounds familiar, right? It's the same as in React before hooks. So the key takeaways from that presentation I want you to have, it's WebAssembly solve some problems with parse and git sailing. You can read here in Almanac in section of performance. So yeah, Blazor WASM brings C# to the browser without sacrificing the JS interop. So you can have both. And yeah, interop keeps JavaScript as a first-class citizen here. It's not JS replacement, it's just, in my opinion, extension, which can bring you a lot of good things. Thank you.
One, two, three. Oh, yeah. Thank you so much. It was kind of a fun thing to see the components in Blazor that reminded me a lot of Svelte and Astro for some reason, which is kind of a similar-ish style of mixture of code and the markup itself. Right, do we have any questions? We have time for exactly one question, the very quick one. There you go.
Hey, thank you for presentation. Just wanted to know, I saw this full presentation and still do not understand where exactly it can be used. Yeah, do you have any real-world examples of using such a thing?
Yeah, and the key factor here will be your project, what you want to achieve. If you need some additional performance in your web application, so because you can create very performant code and wrap it in the WASM. So if you have some, 3D processing and so on and so forth. And Blazor gives you a lot of choices here. So you can create this Blazor WebAssembly app, but when it comes to different types of Blazor, you can, if you want to build, desktop application and mobile app, you can use Blazor. If you want to create some, even a commerce, it will be working as well, I think. But for me, from my experience, if you have .NET developers in your team who can guide you sometimes when it comes to building more performant code, it's a key factor, yeah. And yeah, if you have .NET stack, you want to migrate from some legacy, it's also a good choice. From my perspective, it wouldn't be my first choice when it comes to creating blog, right? But when you have back office applications, when you have some applications you want to give your clients and you want to wrap some additional features, code, for any kind of reasons you can have, it's your actually a good choice as well, I think.
Okay. Excuse me. One very quick remark. We have a question from our YouTube audience on the stream, which Chris will promptly read right now.
Yes, hello. The question from M is, what are the hardest types of bug that are specific for using Blazor in C#?
Honest question. I think when it comes to debugging, these tools from .NET, connected to .NET brings you a lot of features you can use for debugging. But if you have complex application and you have, let's say, I haven't showed that, but there is here in this demo application the comparison between calculating some prime numbers in JavaScript and in C#. You will see some problems, and if you will launch, just simple .NET runtime in debug mode, it will be not much performant. It won't be good at all, I think. You need to calculate how much you want to put effort to compilations. And I created in README the way you can compile the same code, and you will get more performant solution here. So from my perspective, performance is the most problematic.
All right. Well, thank you so much. And let's give him a hand. Once again, thank you. It was lovely.